We're all raised with this really comfortable idea of certainty. I mean, think back to school.
Right.
You're taught that a good argument follows this, this strict structure: claim, evidence, conclusion.
It's a formula.
Exactly. Or you're in science class and you learn that water boils at precisely 100 degrees Celsius. Period. No exception.
A universal fact.
We're basically conditioned to hunt for that single, unified, undeniable truth. But what if that whole quest for singular certainty in how we argue in logic and even in the hard sciences is, well, fundamentally flawed?
It often is. And that quest can be, as our sources suggest, not just futile, but actually kind of pernicious to real progress.
Okay, so that's what we're getting into today.
Yes. This deep dive is all about a fascinating connection, a synergy between two fields that honestly don't usually talk to each other.
And those are?
On one hand, you have critiques of how we teach argumentation, specifically the Toulmin model, which is just dominant globally. And on the other, critiques of scientific realism, led by philosophers like Hasok Chang and his idea of active realism.
So our mission today is to unpack these sources, arguing that we need to strategically move away from those abstract, monistic ideals.
The search for the one right answer.
Right. And instead, we should embrace knowledge that's rooted in context, in what actually works, and in the messy reality that competing but still coherent viewpoints can and maybe even should coexist.
We're going to see why the world's favorite template for essays falls short in the real world. And also how historical scientific truths, things like the failure of phlogiston theory or the surprising instability of water's boiling point, show that knowledge isn't so much discovered as it is actively invented through successful practice.
Okay, let's do it. Let's unpack this shift from certainty to context. So let's start where a lot of us first really learn to structure our thoughts: argumentation. If you've taken a writing class, I mean, pretty much anywhere in the U.S., from high school to university, you've run into the Toulmin model. It's the undisputed champ of writing curricula.
Oh, absolutely. It's praised because it gives everyone, students, teachers, a common vocabulary.
Right.
It breaks down an argument into 6 pieces. You have the claim, which is what you're asserting.
Your main point.
Exactly. Then the grounds, or data, your evidence, and crucially, the warrant.
The warrant is the big one, the one that's usually unspoken.
It is. It's the general principle connecting your evidence to your claim. After that, you've got backing, which supports the warrant, a qualifier, like probably or possibly.
How certain you are.
Right. And finally, the rebuttal, which outlines the conditions where your claim might not hold up.
And you can see the appeal, right? It gives instructors this standard language to diagnose writing. They can look at a paper and say, okay, your grounds are weak here, or your warrant is missing.
And it serves as a great bridge, too. It lets STEM educators teach scientific argumentation because it gives a consistent way to talk about justification across totally different fields.
But the sources we looked at point to some pretty big problems when you try to apply this model to, actually writing something.
Huge problems. First, it's great for analyzing a single small point-a-micro-argument. But just knowing the 6 parts doesn't help a student compose a well-organized macrostructure.
Meaning the whole essay.
Exactly. A paper isn't just a checklist of 6 items. It needs flow, an introduction, a conclusion, things the Toulmin model just completely ignores.
So it helps you build one strong brick, but not the whole house.
That's a perfect analogy. And the terminology itself gets really confusing for students.
How so?
Well, think about the word qualifier. In Toulmin's system, it's a small word like probably. But in composition, a qualification is a much bigger idea, like a whole paragraph that limits your argument.
Oh, I see. Or rebuttal versus counter-argument.
Precisely. Students get tangled up trying to map the philosophical term onto the larger structural piece of an essay they're trying to write.
And it seems like the deepest critique is about the very purpose of arguing in the first place.
It is. The model is so often taught as a tool for justification. For building your case, it's missing a key element: deliberation.
The process of actually weighing the options.
Yes. The critical process of looking at opposing views fairly to figure out which answer is, the strongest or most beneficial after you've considered everything.
So how do the critics suggest we fix that gap?
A lot of them point to other frameworks, like pragmadialectics.
Oh, the pragma what?
Huh? Yeah. Pragmadialectics. It's basically a theory that sees argumentation as a kind of structured discussion to resolve a disagreement based on the merits.
What's more of a rule book for a good faith debate?
In a way, it provides these critical questions like, Are we following the rules of rational debate? Did we analyze the other side correctly that force you out of just justifying your own view and into a genuine critical assessment?
Which is fascinating because that brings us to Toulmin's original intent. He wasn't designing this for a high school composition class.
Not at all. He built it as a philosophical weapon.
A weapon against what?
Against the ideal of abstract formal logic. That whole Cartesian quest for certainty that assumed all good reasoning should be like a mathematical proof. Toulmin's big idea was that logic should be more like generalized jurisprudence.
Like a court of law.
Exactly. It should focus on contextual judgment, on standards of proof that make sense for a specific field, not on some universal abstract criteria.
And this gets to his key distinction between analytic and substantial arguments. Can you break that down for us?
For sure. An analytic argument is basically self-contained. The conclusion is already baked into the premises. The classic example is 2 + 2 = 4. No new information is created.
Got it.
But a substantial argument, which is most of what we argue about in the real world, predictions, ethics, court cases, requires what Toulmin called a type jump.
A leap.
A leap. You're jumping from data about the past and present to a conclusion about the future, or from facts to a moral judgment. Formal mathematical logic completely breaks down here because it treats the analytic argument as the only valid model, and it just can't handle that necessary jump.
Okay, so if argumentation has to be contextual and let go of that analytic ideal, we have to ask the big question. What about science? I mean, that's the one field that's supposed to be all about the singular capital T truth.
And that is our perfect transition to the philosopher of science Hasok Chang, who applies a really similar, pragmatic, contextual turn.
So he's doing to science what Toulmin did to logic.
In a big way. Traditional scientific realism, sometimes called correspondence realism, is all about seeking that God's eye point of view.
The idea that our theories perfectly map onto a reality that exists completely outside our minds.
Right, and Chang just flat out rejects this as a futile and pernicious philosophical dream.
And he's got history on his side with the pessimistic induction.
He really does. The historical record is just littered with incredibly successful theories that people were absolutely sure about, like phlogiston in chemistry or the luminiferous ether in physics that were later completely thrown out.
So the thinking is, if they were so sure and so wrong,
then we have to be humble enough to assume, as one Nobel laureate grimly suggested, that our best theories today will probably be laughed at in 200 years.
That's a tough pill to swallow. It encourages a kind of humility, but doesn't it also risk sliding into total skepticism? If we can't be sure, are we just making it all up?
That's the key question, and Chang's answer is to pivot. He moves the focus away from belief and toward practice.
Okay.
He calls his approach active realism, and its core concept is something he calls operational coherence.
Operational coherence. Let's break that down.
For Chang, knowledge isn't a passive thing you just believe. It's a state of active agents. It's about the aim-oriented coordination of your thoughts and your movements.
So less, is this true, and more, does this let me do what I want to do?
Precisely. Instead of asking if a theory matches reality, he asks, does this system allow us to achieve our aims successfully? It's basically doing what makes sense to do inside a practical system.
So reality itself is defined by what works.
To an extent. He defines an entity as real, to the extent that there are operationally coherent activities that can be performed by relying significantly on its existence.
Can you give us a concrete example of that? It's a bit of a mouthful.
Sure. Think of a positron. No one has ever seen a positron. But a PET scan, a positron emission tomography scan, is a technology that relies completely on the idea that positrons exist and act in very predictable ways.
And PET scans work. They find cancer.
They work. The activity is coherent and successful. And because of that, the positron is deemed real. Its reality is grounded in the success of the operation.
And truth works the same way.
Exactly. A statement is true to the extent that operationally coherent activities rely on its content. He calls it truth by operational coherence.
Okay, that makes a lot of sense. So let's see this pluralism in action. Let's start with chemistry and that phlogiston theory you mentioned.
Right.
Most of us learn the history of chemistry as this, the simple story where the good guy wins. Lavoisier's oxygen theory comes along and just proves phlogiston theory was wrong. The bad theory lost.
And Chang's work completely rehabilitates phlogiston. He argues the theory was actually incredibly successful. It explained all sorts of reactions, like how a metallic rust could be reduced back to metal by heating it with hydrogen. It even made novel predictions that turned out to be right.
So it wasn't wrong, it was just A different system.
A coherent system with different priorities. And Chang argues that its too rash abandonment as an unwelcome rival was a huge mistake.
Why? What did we lose by throwing it out?
We lost important conceptual resources. Phlogiston was primarily about energy transfer, this idea that a substance, phlogiston, was released during burning. Oxygenism, on the other hand, was primarily about weight and mass. They were successful in different areas.
But they have to contradict each other at some point, don't they? How can both exist?
Well, not always, because of something called semantic incommensurability.
That sounds complicated.
It just means the key terms in one system can't be neatly translated into the other system. What a phlogiston chemist meant by the word element was fundamentally different from what an oxygen chemist meant. They weren't always even arguing about the same thing.
Wow, so they were talking past each other.
In many ways, yes. And because of this, some chemists in the 18th century actually created coherent hybrid systems. They'd use oxygenism to track mass, and they'd use phlogiston to explain energy and heat transfer.
They used both at the same time because both were useful.
Pluralism was productive. It wasn't a fight to the death. It was about using the best tool for the job.
That really changes how you see the history of science. It's so much less linear. Okay, let's turn to something we assume is absolute bedrock, the temperature of water.
The famous 100 degrees Celsius.
It's a universal constant, or so we think.
That belief is exactly what Chang wants to dismantle. He shows that the very concept of temperature was invented. It was coherently invented through human practices, refining thermometers, setting standards for brewing or medicine.
So 100 degrees Celsius became a reality because it was useful. It enhanced our operational coherence.
Exactly. But the actual physical reality of that number is, well, shockingly unstable.
Okay, give us the facts. Challenge my certainty.
All right. The sources cite historical reports from scientists like Gay-Lussac, who showed water's boiling temperature changes by several degrees, just depending on what kind of container you use.
Wait, really?
He reported a difference of 1.232 degrees Celsius between glass and metal vessels.
Over a full degree just based on the pot. That's wild.
And that's before you even get to dissolved air. If you remove dissolved air from water, you can raise its boiling point by about 10 degrees.
10 degrees.
One scientist in the 18th century, Deluc, got it up to 112.2 degrees Celsius before it just exploded into steam.
Wow.
And if you're really careful, you can suspend tiny drops of water in other liquids and heat them up to an incredible 178 degrees Celsius without them boiling.
178 degrees. Okay, that shatters the whole idea of a fixed boiling point.
Right.
What does that do to the underlying theory?
It creates a massive philosophical problem. Standard thermodynamic theory assumes a sharp boundary between liquid and gas. It theoretically precludes this kind of variation at a fixed pressure.
The theory demands certainty, but the practice shows chaos.
It does. So if the facts contradict the theory, what do?
Did they throw out thermodynamics?
No, of course not. They took an operational approach. Modern engineers designing boilers often just sidestep the water's actual temperature.
What do they focus on instead?
They focus on the temperature of the heating element and how much it exceeds the normal boiling point.
So they focus on the input they can manage, not the messy, theoretically unstable output.
Precisely. They shifted from seeking theoretical certainty to optimizing operational success. It's pure operational coherence in action.
This brings us right to the synthesis. If you put Toulmin and Chang side by side, the lesson is exactly the same.
It really is. We have to abandon this hunt for universal, field-invariant standards of certainty that come from that mathematical analytic ideal.
For Toulmin, the standards for a strong argument are totally field-dependent.
Right. He'd say that words like possible, probable, or conclusive have a constant force. Conclusive always means we can stop thinking about this.
But the standards for what counts as conclusive change completely.
Absolutely. The standard for concluding someone is guilty in court is beyond a reasonable doubt. That's a specific rule for law. The standard for concluding a physics theory is confirmed is totally different. It's about peer review, reproducibility.
And the standard for concluding who will probably win the Super Bowl is something else entirely.
Exactly. The very meaning of logic changes depending on where you're standing.
And Chang just mirrors that perfectly for science. Instead of, what's the one universal truth, he asks,
what's the most operationally coherent system for this specific goal? Science progresses when you have descriptive pluralism, acknowledging that other successful systems exist, like phlogiston, and you couple that with normative pluralism.
Which means actively looking for alternatives.
Yes. It's the only way to avoid that trap of calling all past theories false. which then forces you to admit our own theories are probably false too. Instead, you see them as successful systems that just had different aims.
The practical advantage of this whole mindset feels huge, especially for all of us trying to navigate this post-truth world.
It is. You stop searching for some timeless, perfect answer, and you start looking for what works, what is reliable right here and now in this context.
So we've gone from the structure of a 5-paragraph essay to the very foundations of scientific reality.
And the lesson is the same across the board. Sound reasoning, reliable knowledge, they don't come from rigid adherence to some abstract ideal. They come from operational coherence and context-sensitive evaluation.
Which leaves a final, really crucial question for you, the listener. If knowledge is only meaningful in the world in which we live, and it's judged by the success of our practical aims, how do we apply that standard to really contentious fields, like economics or politics or ethics? What happens when different groups, say political parties or social movements, are operating with totally different but internally coherent definitions of what success even means? What's the standard for coherence when the goals themselves are fundamentally at odds? That's something to chew on.